Chapter 4, Chemical Quantities and Aqueous Reactions. So we hear a lot about the greenhouse effect and about global warming and how carbon dioxide levels are causing problems. I think it's helpful to understand just briefly the science behind that. So there are what are called greenhouse gases in the atmosphere. And this is a good thing, because if we didn't have these greenhouse gases, our planet would be really, really cold. So those gases let the sunlight come in to our atmosphere, they warm the Earth's surface, and they prevent some of the heat caused by that warming from escaping. So this is good. The balance between energy coming in and going out is what creates our average temperature. So you've got sunlight coming in and warming, and then some of it escapes, but some of it is trapped. And that's a very, very delicate balance. So scientists have measured an average 0.7 degrees Celsius rise in atmospheric temperature since 1860. Okay, that's a long, long time. 0.7 degrees Celsius. You could argue whether that's a significant increase or not. They've also measured atmospheric CO2 levels, and they see that these have risen 38%. Now, one of the questions is, are these two trends causal? Meaning, does the increase in CO2, has that caused the temperature to rise? Has the temperature rise caused the CO2 levels to rise? Or is it just a coincidence that they're both going up? So if we look at carbon dioxide concentrations, we see that it's gone up from below 290 parts per million to around 400. We look at global temperature, and you see there's a lot of variation. There's times where it goes up, and then it comes back down. It's a little bit like the stock market, right? You could look at averages, and so the red line here is the 5-year mean, because you can have a really warm year, a really cold year. So where's the CO2 coming from? One source, of course, is from humans burning fossil fuels. And the chemical reaction, one chemical reaction to describe this would be C8H18, which is a significant component of fossil fuels, burning with oxygen to form CO2 and H2O. And of course, that's producing carbon dioxide. But that's not the only source of carbon dioxide in the atmosphere, right? When we exhale CO2. And when volcanoes erupt, they also emit a lot of CO2. And some of them emit CO2 even if they're not actually erupting. So how can we figure out whether this global warming, this increase in CO2 concentration is from our use of fossil fuels or from some natural occurrence? Well, we can estimate and look at how much CO2 can be attributed to the burning of fossil fuels.